Hi, I'm Dr. Nathan Wilson. I'm a researcher and an archaeologist here at the MAX at the Museum of Anthropology of Jalapa, which is part of the University of Veracruz. So, remember 2012? The end of the world? Something about the Maya? So, a lot of that was pretty silly, but what it was based on was not silly at all. Basically, on December 21st of 2012, a major Mesoamerican calendrical system completed one of its major rounds or cycles. So today in this video, I want to talk about that calendar, which is known as the Mesoamerican long count. I want to talk about it a little bit, and I want to explain how it works. So let's begin. So the Mesoamerican long count is a calendrical system capable of registering dates over time. Now, thanks to a number of long count dates that have been found on sculpture and stela in the P10 region of Guatemala right here, we know that Teotihuacan, the large central highland metropolis located near present-day Mexico City right here, along with its Maya allies, attacked the powerful Maya city of Tikal on the date of January 16th, 378. Numerous other long count dates that we can find give us dates of important events, rituals, the births, ascensions, and deaths of important leaders and rulers, as well as dates on which political alliances were formed. Now, this long count calendar system was used in some, but not all, of Mesoamerica over a span of at least 1,000 years, with most of the dates coming from the Classic period, which dates from roughly 200 or 300 AD to about 900 AD. So the long count is often referred to as the Maya long count or the Maya calendar. Now, it's true that the vast majority of long count dates do come from the Maya region, which we can see over here. Thousands of dates have been found on pottery, on sculpture, on stele, and including hieroglyphic staircases. But the long count is not exclusive to the Maya region. In fact, the vast majority of the earliest dates of the long count are actually found on the edge of the Maya region down here, or completely outside of the Maya region, mainly found in the area known as the Trans-Isthmian Zone, starting from coastal Guatemala, crossing through the Isthmus of Tehuantepec, and getting up into central or southern central Veracruz. Now, these earliest dates pretty much date from the 1st century BC to the 2nd century AD. Now, this suggests a possible non-Maya origin for the Mesoamerican long count system, but we continue to have new discoveries and new finds. For example, not too long ago, some discoveries at the Mayan site of San Bartolo have identified the possible use of the Mesoamerican long count system as early as 300 BC. So now we have two questions. One, what is the Mesoamerican long count system? And two, how does it work? Well, as a calendrical system, it records the passing of time. It uses numbers or values to represent quantities of days. Now, this calendar system records a number of days that have passed since a beginning date or a zero date. And by calculating the quantity of days represented by these values or numbers, we can determine how many of days have passed since this zero date and calculate the date represented. Many calendrical systems have existed throughout millennia across different parts of the world. Now, today, the most common calendrical system used in the world is the Gregorian calendar. Now, according to the Gregorian calendar, the date on which I'm recording this video is the 13th of November of 2023. Now, obviously, the long count system does not use the Gregorian calendar. It uses a different system. Now, if we want to understand the dates represented in the long count system, well, we need to establish a link between the long count system and the Gregorian calendar. We need to establish a correlation. Now, a number of correlations have been proposed to link these two calendrical systems, but the most common one used and the most widely accepted is the Goodman-Martinez-Thompson correlation, or the GMT. Now, this is named after those involved in its discovery and development. Now, according to the long count system and according to this correlation, the beginning date of the long count system, or the zero date, is August 11th, 3114 BC. Now, if we can calculate the number of days that are represented in the long count calendar date, we can determine how many days have passed since that 0 date and correlate it to our calendar. So now we have two more questions. What does a Mesoamerican long count date look like, and how is it written? So a long count date utilizes 5 units, and each unit represents a quantity of days. Now in a previous video, I talked about the Mesoamerican counting system. Now this counting system is a vigesimal system. It's a base 20 system. Now the Mesoamerican long count system is a modified vigesimal or a modified base 20 system. So the 5 units used in the Mesoamerican long count system are kin, winal, tun, cactun, y bactun. Now larger units represent multiples of smaller units. Now this is basically the same thing that we do in a decimal system. We can have 3 numbers, for example, 10, 100, and 1000. Now all of these numbers contain the digit 1, but in each number that 1 represents a different quantity, a different value, or different multiples of 10. As this system, the long count, is a modified base 20 system, most of these units represent multiples of 20. So, what do these different long count units represent? And what is the maximum value of each unit? Well, let's start at the smallest unit, kin. Kin simply represents a quantity of days, from 0 to 19. Winal represents units of 20 kin. Therefore, if we have 19 kin and add 1 more kin, the value of kin reverts to 0, and the value of winal is increased by 1. Now the same thing happens in a decimal system. For example, if we have the number 29 and add 1, the 9 reverts back to 0, and we have to increase the digit 2, representing 20, or 2 units of 10, to a 3 for 30, or 3 units of 10, because the 10 spot in this number represents units of 10. 1 winal equals 20 kin, or 20 days. Therefore, 2 winal equals 40 kin, or 2 units of 20 kin. 3 winal equals 60 kin, or 3 units of 20 kin, and so on. Now I mentioned that the long count does not use a true base 20 system. It uses a modified base 20 system. Well, here is where that modified part comes in. The value represented by winal only goes up to 17. If the value increases to 18, the value for winal reverts to 0, and the value of the next larger unit, tun, increases by 1. This means that, while all other units in the long count system larger than kin represent multiples of 20 of the next smaller unit, tun represents 18 winal, not 20. Hence, a modified base 20 system, and not a true base 20 system. As 1 winal equals 20 kin, or days, we can calculate that 1 tun is simply 1 multiplied by 18 for winal, multiplied by 20 for kin. Therefore, 1 tun equals 1 times 18 times 20, or 360 days. Therefore, 2 tun would be 720 days, or 360 times 2. 3 tun would be 1080 days, or 360 times 3, and so on. The value for tun ranges from 0 to 19, much like kin. Raising the value of tun from 19 to 20 means that the value of tun reverts to 0, and the next larger unit, cactun, is increased by 1. 1 cactun equals 20 tun, and as 1 tun equals 18 winal, and 1 winal equals 20 kin, the number of days represented by 1 cactun is 1 times 20 times 18 times 20, or 7,200 days. The value for cactun can range from 0 to 19. If we have 19 cactun and add 1 more, the value for cactun reverts to 0, and the value of the next highest unit, bactun, increases by 1. Therefore, 1 bactun equals 20 cactun. Going back to the calculations, the quantity of days represented by 1 bactun would be 1 times 20 for cactun, times 20 for tun, times 18 for winal, times 20 for kin. 1 times 20 times 20 times 18 times 20 equals 144,000 days. So now for a quick recap. Now, kin simply represents a number of days from 1 to 19. 1 winal represents 20 kin. 1 tun represents 18 winal. 1 katun represents 20 tun, and 1 baktun represents 20 katun. So now that we have a basic understanding of the units involved and the multiples that we need to use, let's work with an actual date from the Mesoamerican long count system. Let's determine what date it represents in the Gregorian calendar. And lucky for us, right next to me is the famous La Mojara Stela. Now this stela comes from South Central Veracruz, found in the Acula River, or the Rio Acula, and it is the longest text written in Epi-Olmec writing. And more lucky for us, it has not one, but 2 dates written using this long count system. So let's work with this piece. In a previous video about the Mesoamerican counting system, I discussed the use of bars and dots to represent numbers, where a bar represents 5 and a dot represents 1. Now here, selecting one of these 2 long count dates, we can see a column which includes 5 numbers. And we're going to read this from top to bottom, because in this case, the number, or the long count system, the numbers are organized vertically in descending order. So the first number, the top number, represents the number of baktun, the second, the number of katun, the middle number, tun, and so on. In this case, what we can see here first, and again starting from the top for baktun, we can see 1 bar and 3 dots, 5 and 3, or 8. The second is just 1 bar, and that represents 5. The third, we can see 3 bars and 1 dot. Now, each bar is 5, so 3 bars is 3 times 5, 15. 1 dot more, 15 plus 1, 16. Next number we can see is 1 bar and 4 dots, 5 plus 4, 9. And the last one, we can see 1 bar and 2 dots, 5 plus 2, or 7. So what we have here is 8 baktun, 5 katun, 16 tun, 9 winal, and 7 kin. Now, to show you, the common way to render this, or to write this in academic literature, can be seen here. Now that is 8.5.16.9.7. So, what is this date in terms that most of us can understand? Which is to say, what would this date be in the Gregorian calendar? Let's start with the smallest unit, kin, and work our way up. 7 kin is simply 7 days. Easy. 9 winal would simply be 9 times 20 kin, or 180 days. Now 16 tun, remember that 1 tun is 18 winal, so 16 tun is simply 16 times 18 times 20, or 5,760 days. Now 5 katun. Remember that 1 katun is 20 tun, therefore 5 katun is 5 times 20 times 18 times 20, or 36,000 days. Last, we have 8 baktun. 1 baktun is 20 katun, so 8 baktun is 8 times 20 times 20 times 18 times 20, or 1,152,000 days. Now we just have to add up these 5 different values and we have our total number of days that have passed since this 0 date. 1,152,000 plus 36,000 plus 5,760 plus 180 plus 7 equals 1,193,947 days. That is 1,193,947 days after this long count start date, or 0 date, which, as I mentioned prior, has been identified as August 11th, 3114 BC. 1,193,947 days after this date is July 11th, 156 AD. So going back to 2012, what happened on December 21st of 2012 was simply the completion of a major cycle of the Mesoamerican long count, specifically the completion of the 13th baktun. Now on that day, the date simply changed from this date, 12.19.19.17.19, to this date, 13.0.0.0.0, finishing one cycle and starting a new one. So we've come to the end of the video. I hope you find the subject matter interesting, and just one final thought. So the Mesoamerican long count calendrical system is really impressive, and the work put into both understanding how it works and correlating it with the Gregorian calendar have been very important and great contributions to our understanding of the pre-Hispanic past. It's allowed us to identify a number of events registered in writing with the long counts to locate them temporally. So to finish, again, I'm Dr. Nathan Wilson. I'm an investigator here at the museum. And just to let you know, we maintain a YouTube page, so please jump on there and subscribe. Watch the videos, like them, share them. We also have a page on Facebook and Instagram, and in those pages we post a lot of the events that are happening at the museum. And if you find yourself in Jalapa, feel free to stop by. The entrance is free on Sundays. So thanks a lot, and see you next time.